Hey everyone, we're back with another conversation about AI, and I'm joined by Serg Masis. Hey Serg, how are you?
Hi, I'm good.
Yeah,
How are you?
not too bad. As I think we were talking offline about AI and responsible AI. So anyway, before we start, maybe a brief background for the audience, like what do you do? And yeah, let's kick it off about responsible AI.
Sure. I work in agriculture. I'm a data scientist, a machine learning engineer in agriculture. Um, and so like generally what I do is um, process and analyze data involving agricultural yields and plant growth and plant disease and all that sort of stuff. It's very interesting and it's very important right now because we've pretty much run out of arable land in the world, and at least the kind that we can exploit to sustain our population. And we're going to add a few more billion people in the next 30, 40 years. And the question is, can we feed them? Especially considering that people are adopting rapidly Western diets, which are are, that occupy a lot of land. They're very resource intense.
Yeah, that's right. I just thought to mention that for those of you who don't know, Serge Masis has a best-selling book on interpretable machine learning. Big fan of the book as well. So anyway, welcome to the conversation, Serge. Nice to have you.
It's great being here.
Yeah. Anyway,
Um,
yeah. So we were on a thread earlier before we started. You were talking about responsible AI. And anyway, I'll let you start. Like you were feeling a little frustrated, as you said. Let's continue that thread.
well, yeah, like I love the space. I love responsible AI. I like interpreting models. I think it's a must. So I don't want to discourage anybody from buying my book, especially now that there's a second edition coming out soon. And then there's also another book I've been collaborating with, whose title is Responsible AI. And these questions of fairness, transparency, accountability don't get less important over time. They become more important. And so, like when I started this journey, when I started investigating this topic, I'm talking 5, 6 years ago. I mean, I there was nothing about it, and so, but 2 years later, I was already starting to write a book about it. There was already a book out about it. There was, for practitioners anyway, and there started to be a lot more interest in that topic. And as time went by, interest increased, but not in relative terms as much as the general like interest in AI from the general public. We've seen like over the last 2 years, like it's become mainstream. All like terms that used to be like just practitioner terms and industry terms like generative AI are now out in the open. And so like my concern is interest going to continue to the extent that it's needed? Are people are starting to apply these tools uh, the way they should? Because it's all about adoption of the tools. And I realized after investigating that no, they're not getting the interest and adoption. I mean, maybe aspirationally, but when it comes to applying the skills, they're not being applied the way they should. And so to me, that's a big concern because I think they're going to be needed more than ever. And so, like, my um, focus has been okay, how do we get more people involved? How do we expand the tent? And I'm not talking about people necessarily like end users, I'm talking about people developing. So as I was telling Dominique before, like I've been through this before. I was a curious teenager, and I got involved in building websites when it was, not something people discussed. In the, it was in a big hobby to have making websites. And then, by the time I started my first job back in 1999, it was building websites, right? And what I had noticed, since it was just like in 94, 95, it was just a geeky hobby to have till 99, is that now there were millions of people making websites. Of course, more like from an amateur point of view, but they were building it and they were finding issues. They were kind of breaking the mold, and that built in resiliency to the systems that underpinned it. Not only like the usage, but also more people, figure out ways to exploit, um, security flaws in the systems. People figure out how to take design constraints to the limits and so forth. So I started to realize, yeah, like this is a good thing, and we should have this definitely for AI. We should have everybody participate in the development of the technology. So actually, I started with the idea of writing a book about do-it-yourself AI about 2 years ago. And for a number of reasons, I didn't start building it. I already had a publisher on board and everything. I didn't start writing the book till this year. And I'm so glad because so much has happened. And so that's my next project. It's a do-it-yourself AI. That's actually the title of the book. And the idea is to kind of have more people use the technology, even practitioners use it in ways they don't necessarily for work, because it's about the fun of it. If you're told what to do at work, you're not going to be pushing the boundaries of what this technology could do the same way you would do to solve a problem at home. So that's basically what I've been working on for the last few months.
That's really cool. So actually, I picked up three threads from what you just said. I'll tackle the easier one first. So obviously, the motivation for do-it-yourself brings to mind kind of the long-standing, in my view, problems we've had with the adoption of analytics, machine learning, is that there's this heavy technical component that needs to, people need to learn. People need to learn how to code. People need a bit of math. So do you see that changing at all with this adoption of generative AI? And then I'll give you the other
Yeah,
two threads later.
yeah, certainly. I mean, there's layers of abstraction. There's mechanics that have to understand everything about an engine. Like specific parts of an engine to fix the engine. But then there's amateur mechanics that can put together the car and don't have to understand the engine to that degree. And I think that's what we've managed to do with generative AI. I think to the point that now, like, anybody can download a model from Hugging Face and get it working in a number of lines of code. That opens the tent to, it expands the tent to include software developers of all kinds, and they don't have to know about, back propagation and all the complicated math, to actually implement it. And there's been a lot of debate in that sense that, yeah, like, you know, a data scientist and a machine learning engineer should understand the theory to a large degree. And I can agree with that. But we we can also have other categories of people that practice this craft that don't necessarily go to that extent because of the way they're applying it, because of also the limitations that technology provides at that level of abstraction. And so they would have to understand, well, if I want to do this thing with this technology that is a bit more complicated, I'm going to have to learn more about that. So I think we can do that the same way, as I said earlier, that happened with the internet. There were people that early on understood HTML, and all the other technologies started to emerge, like JavaScript and cascading style sheets and so forth, and the other people that only could use like the drag and drop kind of interfaces that came afterwards, and color pickers and things like that. And even the tools that websites that provided hosting would provide that were very simple. So I think we can operate on higher levels now, than we did before, and that's a good thing.
Like the WordPresses and the Squarespaces, right? Kind of,
Exactly,
yeah.
exactly.
Okay, cool. Yeah, no, no. I mean, I mean, I like how you use the mechanics as an analogy. I kind of use automotive analogies as well. Like, in the same way, you can be a very good mechanic. You can, change spark plugs. You can change oil. It doesn't mean you can drive in the Formula One, and vice versa. You can be a good driver. You can do drifting, etc. But that doesn't mean you can change tires. So it seems like we're bifurcating in terms of roles. They're drivers, they're users, rather builders of AI and users of AI. Okay. The other thread I picked up as well is kind of the first thing you mentioned about the interest in responsible AI. Because I was talking to an AI safety researcher in another chat, and he said the ratio of people looking into safety of AI, for example, as opposed to those looking into capabilities, like, deploying it, was really horrible. Like he was saying, it could be a factor of 1:1,000 for every 1,000 people studying, or even worse, studying how to use machine learning or use AI. There's probably just one person looking into the safety of it or the ethics of it. Is that what you
Yeah.
feel also from your end?
Yeah, yeah, definitely. I think there's not enough done in that space. Safety, fairness, there's certainly like the redheaded stepchilds of in the explainable AI or responsible AI space, because like we have a lot of interest in explaining, and that may be completely for selfish reasons, because if you can explain the model, you can certainly kind of fine tune it. You can start to debug it and find ways to make it better. So like I find there's interest in that, which is to me not at all like surprising, but the delta between just explaining, people that practitioners that just explain their models, and practitioners that go to the extents of rigorously testing it for consistency, for robustness, for fairness, uh, for privacy, for all these things, is super vast. And recently, I did like an exercise where I took like 4 years worth of requirements files that I have in my computer. Well, both my personal and my work computer. I'm talking requirements.txt files, environment.yamls, all these files that say the requirements for my Python projects. And I took every package I had installed, and I looked for statistics on it, and then I categorized them. And what I realized that in the responsible AI space, like I've been using like 60 packages over the last 4 years. And one package called chat has more downloads, more GitHub stars, more everything than the other 59 packages that follow. And and I it's great that that package has so much interest, but it can't do everything that you need in the responsible AI space. So I worry about that, because I'm like, well, who's doing adversarial robustness? What practitioners are doing that? The downloads do not sustain that everybody's doing that, because if everybody was doing that with their models, well, everybody that needed to, maybe it would be like 10% of the downloads of TensorFlow or PyTorch, but it's not the case. And as far as fairness goes, yeah, like it's just dismal. All you could add up every package having to do with fairness, all the downloads it has, and it would have less than 1/10 or 1% of the downloads of scikit-learn. And that's not great. I'm not saying scikit-learn is great. I mean, if anything, I would try to urge the makers of scikit-learn to integrate all those techniques, all those methods into their project, because that's like the sole chance of survival I see right now. For a lot of them, anyway.
Is it a matter of, I don't know, ignorance? Oh, anyway, no. I'll ask a different question, which is the third thread I picked up from earlier is obviously when people talk about the ethics and the responsible AI, even AI safety, most of the discussion, at least what I've encountered so far, tends to err more on kind of the policy, the risk management side of things, which is very well and good. But I was hoping if you could also help break down for the audience from a technical standpoint, what does it really mean to tackle safety? Like you mentioned some packages related to fairness, etc. Like maybe what's like the top five or whatever things that as a developer or as an engineer, in case the issue of safety does come up, what would be the first things I would be looking for?
Well, I'd see it from a point of view of quality assurance. Like I've been doing this talk on quality assurance in AI for the last few months. And when I first, started like researching that actual term, you know, uh, to me it was astonishing. There was so little online that connected quality assurance and AI, because it's been applied um, to all kinds of technologies over the last, I don't know, 80 years. From manufacturing to IT, it's embedded in the the, the top like software engineering practices, and it's not something that's in the lexicon of AI people in general. So, like, what is involved in quality assurance? Pretty much everything, from like the design of a system, of an AI system, the user experience to like functional issues. And from functional issues, like probably the ones you would be concerned about is like a consistent level of functional quality. And what I mean about that is that you expect like the predictions of your model to be maybe not, maybe not the same every single time, but within
Predictable range
a,
or consistency.
a consistent range of error,
Yeah.
right? And that's a very hard thing to be able to ensure. Yeah, of course, the inputs are never they're not expected to be the same. Why would you expect consistent outputs? But we can measure the margin of error in a better way than we do right now. Like right now, to me, it's quite astonishing that the practice, even to this day, is, oh, let's give you the mean absolute error or the RMSE or the accuracy. These are all aggregates. I mean, we can't operate completely in aggregates. I'll throw you another analogy. When I started like in this space, like one I like to use had to do with airplanes, because like to me, like the tooling that's needed for responsive AI is much like the very complicated gauges and monitors you see in the cockpit of a plane. Like there's just so many different details you could look at, and they can be all very crucial under many different circumstances, not all the time, but and you have to be moving those levers. If we're operating completely on one like or two metrics, it's like tantamount to be flying the plane and just with one of those simple sticks that used to have on those old planes, right? And the wind can push it anyway, and sometimes you'll have a crash. It's not super reliable, but it can get you from A to B, especially if the conditions are great. But we have to talk about the data conditions. They're not always what you expect. So in that analogy, that's like flying that dinky little plane in a thunderstorm. You can't expect it to be reliable because you don't have all the tools, because it's not robust. It can't withstand that. In any case, even if you were the best pilot. So to create those robust machine learning models, we have to measure all these things with greater precision, with more detail, and stop relying on these you know few metrics that are all aggregate. We have to be looking error as what it is. The error has a distribution, and we can look at that distribution and we can understand that distribution, and we can say, if for these conditions, we can't fly this plane because it's going to crash. we can say that, and we can say in the machine learning, to put it in machine learning terms, we can say, well, we know that when we use this model, when the data input is like this, we can't make a reliable enough prediction. So we can actually abstain from making that prediction. But of course, it takes a lot of effort to come up with these heuristics, if you will, and then do the error analysis to the extent that we can actually do these things. Also, businesses don't want to be able to say, okay, we can only predict 95% of the time. The other 5% is going to have to land on someone's desk for someone to come up with a solution. It's not great in that sense, but it's realistic. That's where we at, and that's for many kinds of problems is where we'll always be, in the sense that like these tools, or machine learning in general was not made to solve everything, or at least solve everything better than a human would. So I think we have to be realistic and determine those constraints. And that's part of what it is to do quality assurance. It's be able to ascertain when the error is insignificant and when it's untenable, um, and all the standards we've heard of, ISO and all those, they focus a lot on that, and as well as all like the management and all the design principles that go into creating systems that can minimize error to that degree.
Yeah, in many ways, and let me know if you agree. Speaking from my own experience, I think what throws off a lot of people that get into machine learning, especially for the first time, is there are many levels of metrics. For example, what most modelers are used to is kind of your base metrics that kind of govern the modeling process. Like you talked about mean absolute error, root mean squared error. That just refers to modeling per se, right? Doesn't really have anything to do with the business side of things. Doesn't have anything to do with, it's kind of like the difference between your RMSE and an R squared. R squared refers to prediction, while root mean squared error looks at, say, residuals, something like that, right? So that's two levels already. But if you look at it from a practical perspective, a bad algorithm is usually a function of bad data, and metrics to measure how bad the data is. Anyone's guess, depends on where you are. And bad data is often the product of bad processes. That's even another whole level altogether. So I wonder how much of it, and I'm not sure if you agree, but my question would be, I wonder how much of it is really also a function of how people are organized. You know what I mean? Let's say a typical project, you have different people looking at different things. And from a modeler's perspective, well, the only thing I can really control is the error rate of my model. Everything else is outside of my control, so I don't care about that. But as a whole, we need to be managing it. I don't know if that makes sense.
It makes complete sense. And that's why when Andrew Nan last year came about with was it last year or the year before last? I don't know, but he came about saying, okay, I'm proposing this new paradigm. Let's stop being model centric and start being data centric. And what that ultimately means is that we're going to pay close attention to the data generation process. And there's a lot of things we can't control there. And there are things that not only we can't control, but are intrinsically messy. I work in a space that is intrinsically messy. And it's not even a people space. People say, okay, any data that has to do with users is something that is going to be difficult. Anything that has to do with human behavior is going to be difficult, right? But that's not the only case. Like we've all seen, like climate change is throwing wrenches into our systems and our understanding of the world and how these different patterns drive things. And among them is the production of food. So food production is, of course, very much connected with the climate patterns that we've come to expect. So like we have different level to kind of that we learn that we can use to increase food production when it's very rainy, or when it's very dry, or but when you have all these different things coming to you at once, a rainy week, a dry week, and then a rainy week, then a dry week, well, there's a lot of things that can go wrong. So like, and also there's of course data entry errors, like for our data collection process. So you end up having to find ways and to overcome these, and not go down the lazy route, which is I'm just going to throw everything in the model and hope it works. And that's I think the notion that a lot of I wouldn't say a generation, because a generation hasn't gone by, but you know at least a decade's worth of machine learning practitioners that did not come from a science background, uh, have learned to apply, which is completely flawed. You know, before, at least, for the first data scientists that came from a science background, and I'm not calling myself one of them, um, they they definitely knew that data had a lot of uncertainty, and that you had to be careful with that. But when you give these things blindly to engineers, they're going to take an engineering mindset, which is, let's just optimize this, and and hope for the best. Um, so yeah, my thought, I'm just summing it up, is data-centric AI, generation process is very important, and there's things that we can correct for, because after all, it is some machine learning exists to be able to solve problems that we can't fix with, like procedural programming, that we can't really understand to the fullest extent. And that's okay. But we have to be aware of that we don't know everything. Just because the model predicts fairly well, it doesn't mean we understand the world, and that we have solved the problem, because we haven't.
Yeah, I mean, I'll ask you a question about that. Like from my background, I came from a finance background. One of my earliest exposures to machine learning was actually in the kind of the capital market scene. So you're doing these trading systems, or later on doing these risk management systems. One of the things that I've always thought was kind of a governing principle is the more accurate your model, quote unquote, the worse it'll perform, because you're kind of overfitting the past. But then we're now in a world where, especially with neural networks, where essentially you're pushing the boundary of kind of almost 100% accuracy. And people make kind of, I think people are making the mistaken assumption that you can treat it like any deterministic process, and forget that there are variations to the outcome. Do you see this kind of as a blind spot now, that especially
Yeah,
we've gone beyond simple statistics, and we're now treating it like a
yeah,
refrigerator, right? You kind of expect the
yeah,
ref to be always cold, but the way these models work, sometimes it'll be a heater rather than a cooler. So
yeah,
does that make sense?
yeah, absolutely. And it's why I stress, especially with time series, but I would say pretty much any problem, you need uncertainty estimations. You need confidence bounds or confidence levels. You need to be able to embed that into your machine learning process. And even though that you might not ever expose it to the end user, it does serve a purpose from a quality assurance standpoint. Because if you have confidence bounds, if you say, okay, well, I want to know what my for this time series prediction, like say you're predicting sales, and you're saying, well, I have this number predicted for next month, and but I have this maybe I fit conformal prediction to it, and so I have like 95% confidence that my prediction is going to be within these two bounds, this upper and this lower bound. That's quite good, because it means, okay, well, you can put that, you can even explain that to the board, and say, okay, well, these are the sales we expect with this, and that's to a 95% and it might be a pretty high range, and that's good, because then you say, well, I mean, that's as good as I can get. I can get sales within these plus or minus things, this amount, with a 95% confidence, and there's still a 5% probability that I'll be outside of it. So that gives people a better understanding of what you're predicting, and to what extent you're capable of predicting what you're predicting. Whereas if you give them a fixed number, you're just, I mean, you're kind of fooling them into thinking, well, and you're even fooling yourself that you're capable of pinpointing a number, because that's the way we think. We might know intuitively that's not what we're doing, but we're still, even in a kind of very subtle way, fooling ourselves that we can actually do that. And also the metrics won't do it justice, because most of the time when I do this exercise, I'll have, let's say, a root mean square error of 10. But, and so I say, well, I got this number plus or minus 10. All right, that might be fine. But then I realized, well, if I use the conformal prediction and come up with the range, actually, like the range between the upper and the lower bound is like 50. And so you realize, well, like if I want to be 95% confident, I can't fool myself in which, like I use like the mean square error and then just multiply it times 2, and I'm getting myself the range I'm expecting. No, it's usually far bigger if I'm using those confidence levels. And then, as I was saying, we can actually use these upper and lower bounds for different kinds of prediction to figure out what is the actual, I'm forgetting what is like the technical term for it, but what is the coverage of these errors, these bounds that I'm coming up with, and they're supposed to match more or less the confidence level that I expect. But that's the great thing about using this sort of technique.
Yeah, I mean, speaking from, like, I came from a finance background, accounting background. Accountants hate ranges, in the sense that you want us. I mean, they're trained to balance equations, balance sheets, right? They hate the fact that it could be higher or lower. And I think there's a natural bias every time you bring it in front of a board or, finance people. They don't care much about kind of the upper bound. If you make more money than you expect, they only hate it when you make less money than when you expect. So everyone's always looking for that middle point, which I feel is kind of a blind spot. So it's always a relief when you have, stakeholders or clients who are actually comfortable getting, even even on a regression equation, people forget your coefficients are actually just the midpoint of a kind of a range. Throws everyone
Yeah.
off. Okay, but I wanted to tease something else. And just noticing that we're kind of burning through the hour very quickly. It's really good. We should save some for the next episode. Anyway, the point I want to tease now is, so we're now in an era of large language models, transformers, and I find it very interesting that people are so shocked about hallucinations when intuitively, let me know if I got it wrong, this is just a function of error rates, in prediction, right? And I find it interesting that the way the current trend is to correct for that using something like reinforcement learning, rather than understand, I don't even know if it's possible, rather than understanding the underlying distributions of the data itself. So now you've compounded it. You're not only not sure about what the outcome can be, you've introduced a deliberate bias because you have another model forcing another outcome to mimic, let's say, how humans would answer. Am I appreciating the problem properly, or is there something else?
Yeah. Like, no. I mean, there is value in understanding the distribution of the data.
Yeah.
But like all these large language models, and especially even the ones that, they're decoder transformers, and
Yeah.
their underlying model, like the base model, is just meant to predict the next word.
Yeah.
So like they have no concept of what, is true.
Yeah.
There's no, it's just regurgitating like a parrot, what it's read somewhere and what is a likely continuation of it. And
Mhm.
so when it formulates all these different, it generates all these different answers to your prompt, it there's no aspect of what's true or not. It's just, yeah, as you said, it's reflection of the patterns that it finds in the data and the distributions it finds in the corpus. It found the massive corpus that is online data. Yeah, so you could do a lot to understand the distribution, change the data to make sure you only put truthful stuff, but that might not even make a difference because you could always use prompt engineering to make it say something untrue. So I don't think there's a brute force way to
To
get out
fix
of
it.
that.
Yeah.
No, I think probably the solution lies in a completely different model architecture that is more sparse, that perhaps has some some constraints, and it could even be a machine learning based constraint. It doesn't have to be something kind of designed by a human. It
Mhm.
could be an adversarial approach where you have like a model that is the one that generates and another one that is, much like it was with GANs, an adversary.
Like again, yeah.
So yeah, so it's trying to find, you know, uh, it's trying to fact check the other one, trying to make sure if there's some kind of flaws, and it's designed to do so. I don't know what kind of metrics would go into that, what kind of design would go, because it's a very complicated thing. What constitutes truth? What constitutes veracity? What is technically correct? Because it's gonna vary depending on the prompt. If you're telling, um, you know, basically a large language model, give me a work of fiction, create scenarios that aren't true. I mean, you're not going to want another model to fact check that
Mm.
because you're basically asking it to make up absurd scenarios.
Mhm.
And so, but if you're asking it to tell you, you know, a definition of something, or if two, what is 2 plus 2, you expect that to be fact checked. So it can vary in accordance to the prompt. So it's complicated because the way we work, I mean, I don't know enough to tell you, of course, how the brain works, and I don't know who does.
Yeah.
I have two brothers that are neuroscientists, so it's the sort of thing I've heard a lot of course, like we have different parts of the brain that focus on different things, and they kind of work in tandem and against each other, you know. So we we have a very simple architecture to our models. They may be massive in the amount of parameters they have, but they don't have the different areas of specialization that the brain has. And I'm not saying we have to make models just like brains, but we can certainly learn from that. We can learn about specializing pieces. And maybe that's the answer, I think, more lies less in the data. And this is one of those few cases, which you'll hear me say, like we have to improve the model
The
architecture
model
rather
itself.
than
Yeah.
the data. Because usually I go with data first, but when you're using the entire internet, of course, there are things you can do, and they're already doing them. But I think that the answer lies more in the model architecture, in streamlining it, in specializing pieces, and in there's new kinds of architecture that come out that are even more sparse than transformers, because the transformers were an improvement from the previous things that we were using, like
Mhm.
LSTMs and everything, because the way the the way they connect different words to each other is much more efficient.
More efficient.
Uh,
The attention
yeah,
mechanism and all that stuff. Yeah. Okay.
exactly. So like there are things we can do there to make it even more efficient. And Jeffrey, and there's also things on the hardware side. Jeffrey Hinton recently endorsed analog computing, and that's completely on the hardware side. But I wonder, like humans, we use a combination between analog and digital signal. We don't just use digital.
Mhm.
So that's what allows us to have these this very the way we think is more like in the gray. Like you can't ask a human an exact percentage of, confidence in something or an understanding of something. They say more or less this. There's like all these different things that come from more like an analog thinking. So that has its pros or cons, but there's certain things we can do with a lot of precision with analog computing. You can do actually just with the concepts of conductance um, and and wattage, you can come up with matrix quantification
Mhm.
and done for a fraction of the electrical consumption that is currently done with digital computing. And it's done typically with just working with the signaling that already naturally exists in in
In
electrical signals.
in
And
hardware, right?
it's
Yeah, exactly.
exactly it's also very similar to the way the brain sends those signals as well. So I think there are things we can learn from that, and if we apply it, and we can probably safeguard things in a much more efficient manner. Because one of the issues that we face is that given the amount of you know the resources needed to train large language models, the companies that have the resources to implement constraints, safety mechanisms, iterate across different training data sets and so forth, usually have a lot of resources.
Yeah,
So
it's natural
if we
monopolies
lower the
actually.
bar, exactly. So we lower the bar for entry so that we're using the kind of hardware that can scale this a lot quicker and more like in a much more nimble fashion. Like we're going to allow for greater innovation in the space.
Yeah. One more thing. Well, of course, we're running out of time, but I just wanted to ask about what do you think of fine tuning? Because that seems to be kind of a like an interesting compromise where you have a base
Yeah,
model, it kind of knows enough from the general internet about how sentences work, but
yeah.
you force it to look at a kind of a smaller knowledge base, so you're not necessarily relying on it for like broad knowledge. It seems to work, but from a responsible AI perspective or a risk perspective, do you think that that solution is actually workable or sustainable in the long run?
I I think it is it it's actually great in the sense that you're not retraining models on larger data sets
Yeah.
unnecessarily. So it's less resource intensive, and it's actually instead of throwing like the big model at problems it was never trained to do and hoping for the best, um, you know, like you would like with a zero shot classifier or something to that extent. Like you're actually training it on very specific data,
Mhm.
which to me makes a lot of sense. And it's also analogous to the way people iteratively learn.
Yeah.
So, and I think that's a good thing. But I think the problem I have with it is that it doesn't, if we're relying more and more on this, we're going to be doing working on less innovation, on creating new architectures for deep learning, or we're going to be doing less on tweaking the data sets themselves. Um, and like I think it takes away from the kind of innovation we could do via everything else, because it's a sort of technique that can be overexploited,
Like a
I
stopgap
believe.
measure rather than
And
an actual step up.
exact
Yeah.
exactly. So I actually like with all these LLMs, there's been a lot of talk on using LangChain,
Yeah.
on using a chained approach, integrating tools, and I think that can open the door to many other ways of interacting with large language models that don't involve fine tuning. Of course, a lot of people in that space say, well, the way the large language models are built right now, like sometimes you just do all the prompt engineering, all the memory handling and vector databases, all that stuff, uh, as long as you have to understand how to best fine tune your model, because eventually it'll come all to fine tuning, because no large language model now is good enough to handle every single like use case that you can come up with, because it just can't.
Yeah. Or if people try to, it'll be so big, so big or
Yeah,
too expensive to build. Okay. Got it.
yeah,
Well, it's an hour, so I think we're gonna have to save some for the next episode. But maybe, Serge, from your perspective, something to give away to the audience about. Let's go back to your original frustration about responsible AI. If there's a way that you think we can reboot kind of that sector, get more people interested, some parting thoughts, before we end the episode.
Yeah, like well, for people that already heard of the term and are interested in it, I'd say, well, look into it. There's a lot more than explainability. If they're passionate about fairness, if they're nitpicky about quality, there'll be like different areas of them. If they're interested in adversarial robustness, if they want to have kind of a hacking mindset and want to figure out how to trick a machine learning model, I mean, those are like interesting kind of areas they can explore. And I think it's not necessarily has to come from a place of, I'm a good person and want to do ethical things. Because once we put it in that light, and I'm not I'm not throwing shade at ethical IA folks, but what I'm saying is once you do that, a lot of people they're like, well, I I mean, I I don't necessarily connect with all of that. It's not the one thing I want from machine learning. No,
Sure.
I want, from a business perspective, you want them to be profitable.
And
But for them
reliable.
to be profitable, they have to be reliable,
Yeah.
right? And for them to have a long-term effect and not kind of I alienate people, potential customers, they can't have a reputation stain where people are saying, oh, that company does these unfair things. Their models are, discriminating towards this group or another. So there's also the fairness kind of in there as well. So I think, yeah, like you can see that holistically as every technology has come up, it's gone through these growing pains where there's been people against them with the pitchforks and everything saying it's going to be the end of the world if we adopt this technology, and others that have been curious enough to push the boundaries and actually improve it. And that's what I'm hoping for, by trying to expand the tent and get more people involved, because we need those kind of people. We need people that will play with it, break it, and then urge the industry to fix it and to come up with standards. Because like we can try to regulate all we can right now, but what we need is more tools and adoption of tools for responsible AI practices.
In something that can be innovated, like how we build models. We should be able to innovate
Yeah,
how we police them. Okay.
yeah,
So anyway, I want to thank you, Serge, for giving us some of your time. And obviously we're going to be waiting excitedly for your next book. But in the meantime, we'll catch you later. Thanks a lot for your time.
sure, sure thing.